Welcome to The Explainer. Today, we are going to break down one of the most powerful and, yeah, one of the most complex ways to scale a database, sharding. Ever wondered how these massive apps that we use every day can handle millions of users all at once? Well, this is a huge piece of that puzzle.
All right, so to really get this, we have to start with the problem it's trying to solve. Let's talk about something every successful app eventually slams into: the scaling wall. So just imagine this. Your app blows up. Your user base doubles overnight. That's amazing, right? But in the background, your single, trusty database starts to groan. It's creaking under the pressure of all those new reads and writes. Suddenly, everything's grinding to a halt. Queries are timing out, and the user experience just tanks. When you hit that wall, you've basically got two choices. You can scale up, which just means you buy a bigger, beefier, more expensive server. But there's a hard limit to that. You can only buy so much power. Or you can scale out. Instead of one big machine, you add a bunch of smaller machines and spread the work around. And that is exactly where sharding comes into the picture. Okay, so scaling out is the goal, but how in the world do you do that with a database? I mean, it's not like you can just chop it in half. Well, actually, you kind of can. The answer is this really powerful architectural pattern called sharding.
So what is a shard really? At its heart, a shard is just a horizontal slice of your database. Think of it like this. Instead of one gigantic phone book for the whole country, you've split it into a bunch of smaller books. You know, one for A through M, another for N through Z. You're literally splitting the rows of your data across smaller, much more manageable databases. And this is a really key distinction, right? This is different from what's called vertical partitioning. That's where you might split a table by its columns, like you put user profiles in one spot and their billing info in another. Sharding is all about splitting the rows.
And you know, here's a little bit of trivia for you. The name shard doesn't actually come from some stuffy computer science paper. It came from a video game, Ultima Online, way back in 1997. They had way too many players for one game world, so they created copies, or shards, of the world to spread everybody out. Same exact problem, same exact idea.
All right, so that's the big idea. But how does this whole thing actually work under the hood? Let's get into the nitty-gritty, because there are a few key pieces you really have to understand for it all to click.
You've really got three main players in any sharding setup. First, you've got the shards themselves. Those are the individual databases. Second, and this is crucial, you have the shard key. Think of it like the zip code for your data. It's a specific column, like a user's ID, that tells you where that user's data should live. And third, you have the routing logic. This is the brains of the operation that reads that zip code and makes sure the query goes to the right address. So, how does that routing logic decide where the data goes? Well, there are a few common strategies. You can use a hash-based approach, where you run the shard key through a math function to get an even split. Or you can do range-based, which is just like our A to M phone book example. Or you can even have a directory, basically a lookup table that explicitly says this key goes to that shard. Each one's got its own pros and cons, a classic trade-off between simplicity and flexibility. So let's walk through what happens when you need to find some data. Your application sends a request to a router. Now that router acts like a traffic cop. It looks at the shard key, the zip code, and instantly knows which shard holds that data. It sends the request only to that one specific shard. It doesn't have to search the whole system, just the one little piece, which makes it incredibly fast. So, why would anyone go through all this trouble? I mean, it sounds complicated, right? Well, it is, but the payoff is huge, especially when you're talking about applications that are operating at a massive scale. The advantages are pretty amazing. First, massive scalability. You just keep adding more servers as you grow. The sky's the limit. Performance gets a massive boost because any given query is only searching a tiny fraction of the total data. And you get much higher availability. Think about it. If one shard goes down, it doesn't take the entire application with it. It only affects that one subset of users. So how do you get that high availability? Well, usually you make copies or replicas of each shard. If the main server for one shard suddenly fails, an automatic system just kicks in, and it redirects all the traffic over to a healthy backup copy. For the users on that shard, there's little to no downtime. It's a pretty slick system. But, and this is a huge but,
Sharding is not a magic bullet. It is not a silver bullet. While it's fantastic at solving the scaling problem, it introduces a whole new world of complexity and some really nasty potential problems. One of the absolute biggest nightmares is creating what's called a hotspot. This happens when you pick a bad shard key, and most of your traffic ends up hammering a single shard. Imagine you shard your users by country, and then a huge event happens in one of those countries. Bam, that one shard gets completely overwhelmed, and you've just created a brand new bottleneck, completely defeating the whole point of sharding in the first place.
And it's not just hotspots. The day-to-day complexity just goes through the roof. Trying to do things like a simple SQL join across multiple shards, it's a performance nightmare. And basic operational stuff, like backups, monitoring, or changing your database schema. Things that used to be easy are now a massive headache because you have to coordinate it all across dozens, maybe hundreds of databases. Okay, so we've got these incredible benefits on one side, but also some really scary drawbacks on the other. So where does that leave us? What's the final verdict here? And this right here is probably the single most important thing to remember about sharding. You should think of it as your absolute last resort. Before you even think about taking on this kind of complexity, you need to make sure you've squeezed every last drop out of the simpler solutions, things like better caching, using read replicas, or just buying that bigger server. So ultimately, it all comes down to this one question you have to ask yourself. Is the pain you're feeling right now from your scaling problem worse than the pain you're about to feel from implementing and managing this incredibly complex, but yes, incredibly powerful solution? The answer to that question is what will tell you if sharding is the right move.